So next we're going to talk about some special relationships we can have in terms of particular angles. First, we're going to look at what are called parallel vectors, where vectors being parallel has kind of the same meaning as lines being parallel, thinking in terms of more classical geometry. That is, you've got a pair of them that never intersect and have the same slope. Where if we want to talk about that in terms of angles, you can see that if we have that the angle between them is either 0 or 180 degrees, where you get those values in particular based on whether they're going in the same direction or opposite directions. The more interesting case is where we have vectors that are orthogonal. And orthogonal is a slightly more general term than what you're probably used to for thinking of situations where 2 points have a single intersection where the angle between them is 90 degrees. You might think that that is what's called perpendicular vectors, and yes, technically it does have that similar sort of meaning, but orthogonal is a slightly more general term, and it hints towards another thing that you'll see maybe later if you go far with math called normal things, where it has, again, a very similar meaning, but it's a bit more general, even more so. For us, though, what we focus on with orthogonal vectors is that if two vectors are orthogonal, we must have that their dot product is 0. And you can see that as a direct result of our alternate formula for the dot product, where if we have v dot w, we'll have the magnitude of v times the magnitude of w times cosine of the angle between them. And if the angle between them is 90 degrees, or pi over 2 radians, then that cosine will go to 0, and so this whole term will go to 0. And this gives us a quick way to check if our vectors are orthogonal. You don't have to worry about finding that angle using the formula. We can just see, is the dot product 0? And that's what we'll get with our next example. So for this example, we want to check if the vectors v equals I plus 3j and w equals 6i minus 2j are orthogonal. And we'll do this with the dot product, where here we just take v dot w, where that will mean looking at 1 times 6 plus 3 times negative 2, and we will get 0. So they are orthogonal. And in particular, you'll probably notice as you're looking at these things for orthogonality, there are some special types of relationships where it looks like, these are kind of multiples of each other. They're negative reciprocals, as it were, in terms of if you multiply one by that constant through there, you get the same sort of thing, and that actually should make sense if you think back to how you can tell if two lines are perpendicular. But anyway, this is the main idea that we have for orthogonality and parallelism in terms of vectors. Next, we're going to take this in another direction to talk about a thing called the projection.